Well, good morning, everybody. It's very nice to see people tuning in. How are we doing this morning? Some people saying hi in the chat, which is fantastic. So how are we doing today? If others want to say hello in the chat, it's interesting. We've got sunny emoji and we have sunglasses emoji, and well, I don't know, maybe some of you aren't tuning in from the same city that I'm tuning in from. Speaking of which, I would like to, I'm not going to do this every single lecture, I don't think, but I am going to ask you again a question about, oops, I've got the wrong date in there. Well, I'll fix the date afterwards. But right now, I would like to ask, where are folks tuning in from? I'm kind of interested to see if like the Monday answers are different from the Wednesday answers, and if the Wednesday answers are different from the Friday answers. So I'd be quite interested to see if there's any difference there. This is something that might change as the semester goes on from week to week. Even it may, you may have more or less activity that you have to be around for on campus. But I am quite curious as to where everybody is. But it's good that people are saying hi in the Top Hat chat. If anybody, so I've noticed, by the way, so we've now returned grades for Lab 1, and we've now had opportunities to do the first 4 exercises, and we've also had lots of Top Hat interaction that's happened, and so people should be getting some idea of how well they understand the material by things like how they're doing in the Top Hat questions. We also have the first assignment has now been released, and I'll talk about that in just a moment. But I did notice, as I was putting together my little spreadsheet of the grades thus far, that there are some students in the class who have not submitted really anything yet, who have not submitted any exercises, who have not submitted a Lab 1, who have not really participated in Top Hat or not very much. So if you're someone who's in that situation, then you should probably get in touch with me and we should probably talk, because you'll need a plan to sort of catch up on material. And we're now getting to the point in the semester where it will be very difficult to catch up if you haven't been engaging actively so far. Okay, so let's have a look at what people said and see if those responses kind of look like they did on Monday. Yeah, so, ooh, wow, an even smaller crew in 2006, more people in 4020, still a good contingent in the library, some other folks in other places on campus, and it looks like the plurality of people are in St. John's but not on campus. Okay, this is all good to know. So, thanks very much for tuning in, and today we are going to continue talking about loops, how we can get computers to do things over and over and over again, and in particular, today we're going to think about how we can get computers to consider one thing after another, after another, after another. And so we are going to think about iteration, and we're also going to think in a little bit more detail about strings. So we already know about the string type, but now we're going to look in a little more detail about what's going on inside of a string and how a string can be used to represent a bunch of individual characters. So remember, we had this tutorial on Monday where I was talking about how we design with loops, and I suggested it'd be a really good idea to work from the inside out. Start by thinking about what's the thing that the loop needs to do every time. So if I'm going to have a loop that calculates something by iterating over or by doing something 100 times, adding numbers together 100 times, multiplying numbers together 100 times, doing something else 100 times. To start with, let's ignore how we get started and how we finish. We'll have to come back to those details because they matter. But to start with, let's just think about what is the step that the loop needs to take every time in order to make progress towards where we're going. And once you figure that out, then the other things like how do we start and how do we finish will fall out a little more naturally than if you fixate on trying to think about the start and the finish without a clear idea of what's going on in the middle. And we did a little example, which was a factorial, and we also talked about Project Euler, and I recommended Project Euler as a great place to look at problems that typically involve loops, and there are lots of problems there that you won't be able to solve yet, but the first few are things that we can now start to solve, things like adding up all of the values below a certain number that are multiples of 3 or 5, for example. That's a great example of something that, although it sounds a little weird when I say it that way, if you do it by hand a couple of times and you think, now how did I just do that? And then you take that and try to translate into an algorithm that you describe in either pseudocode or a flowchart, then you should be able to take that and translate it into Python code. Follow that process, and some of these different problems will, they're kind of interesting to just practice problem solving. Solving problems can be fun, and hopefully you like solving problems if you're in engineering school. And also it'll give you good practice for programming. And so we had the factorial example, we had Project Euler, and now assignment 1 has been posted. And I note that a couple of people have actually already attempted assignment 1, so a couple of people have submitted solutions for assignment 1, so fantastic. People really getting into the game, even though I only posted it last night. But assignment 1 involves writing a word guessing game. And this is, it's not very much like Wordle, but it is ever so slightly inspired by Wordle, just because, Wordle's a thing that everybody's into at the moment. But, so you are going to write a little game that involves guessing. So one player will choose a word to be guessed, and the gameplay will kind of look like this. If I say I'm going to, and it has to be a 5-letter word. So if I try to make the word be Shazam, then my little Python program says, no, sorry, that's not a valid word. What if I say supercalifragilisticexpialidocious? I think that's spelled correctly, maybe not quite. No, that's not quite a valid word. Okay, well, how about hello? Yes, all right. So now that I've input my word, then the other player comes along and they get a chance to guess the word, and they get 6 guesses. So I might say greetings, or I might say quaff, or quest, quench, which isn't even 5 letters long. Queen. Well, I better get it on this last guess, because if not, then it will say out of guesses. Whereas if I input the word gecko, and then the first player came along or the second player came along and said, is it hello? Is it world? Is it gecko? Then it says, that's right, gecko is the word. So it's a very simple little word guessing game. And this will be an opportunity to practice working with user input, with loops, and with things like comparisons. Is something equal to something else? And a really, really, really important note about assignments is, unlike the exercises, assignments are individual work. So the exercises, you could do them with someone else, you could do them with whoever you like. You could work on them together, submit answers to, you submit the work and someone else submits the work. That's all fine for exercises. For assignments, it is not. For an assignment, I'm asking you to solve a problem, and the solution should be yours. You ought to be able to look me in the eye after you submit it and honestly say, yes, this is my work. I did it. Now, that doesn't mean that other people didn't help you understand Python. And, I'm here trying to help you understand Python, trying to help you understand the goals of imperative programming. Someone else can help you understand, well, what is this assignment supposed to do? But no one should be saying, in order to solve this assignment, you just need to do blah, 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 blah. Because figuring out what blah, 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 blah is, that's kind of the core, the crux of the assignment. The assignment is not taking an algorithm and turning it into Python. The assignment is figuring out what the algorithm should be and then turning it into Python. So please remember, assignments are individual work. Question in the chat, can we still submit any number of times? Yes. So GradeScope will be configured so that you can submit any number of times. Kind of like one of the exercises was, though, I'm going to hold back some of the test cases. So you'll see, I don't know, like 12 or 14 or 15 test cases, something like that, in the auto grader when you submit. There's a few extra ones that I'm holding back. So your total grade will be out of 20, but you don't get to see all of the results. And part of that is just to help keep people honest by not letting them say, oh, well, in the test case where the word is earth, then I know that the guesses are going to be blah, blah, blah. So you will not have a successful time doing that. Okay, any other questions? All right, so that's lots of opportunity to practice working with loops, designing with loops. And in fact, I gave you additional exercises and problems that you could work on even in the tutorial. I mentioned stuff at the end. Now, let me ask you a top hat question. And this is not because computer engineering students or any kind of engineering students have to know the answer to this question off the cuff. The reason I'm asking this is to get us back into that loopy mindset. Feeling a bit loopy this morning. So that mindset in which we are doing things one step at a time over and over and over to get a right answer. Hopefully. To get an answer anyway. Hopefully it'll be right. So answers are coming in. That is great. Give it just a little bit longer and we'll see if some more answers come in. All right, I'll close this one out in about another 5, 4, 3, 2, 1, and stop. Okay, and look at that. We had quite a remarkable amount of consistency in those answers. So good job. Okay, so let us continue on our journey through the land of loops. Or the land of loopiness. Anyway, let's continue on our little journey and let's think about iteration. So if I say this current iteration, referring to something that's not about programming, what do you think I'm talking about? What does that English word iteration mean? And there's more than one right answer here, so don't be shy. Go on, type in the chat. What do you think it means? Okay, so yeah, we can mean it. We can use it in the sense of a version. I could say in the current iteration of this document or something, which means that it is a particular version of the document, and it kind of implies that we have worked on several versions. We had a version of the document, that we found some places to improve it, so now we've got a new version. We found some ways to improve it. We've got a new version, so we've over and over and over worked on this document, improved it. Let's see, someone says, isn't it like the newest model? Yep. The repetition of a process? Yep. So again, those things are kind of implying that we have a version of something that has been continually refined, continually improved by some sort of repetitive process, right? So we write a draft, we send it to somebody, we get their comments, we incorporate their comments into a new draft. We send that draft out for comments. We get comments from somebody, we incorporate those comments, we send out another draft. And good writing usually involves several trips around that particular path, which is part of why when something is due at 6 p.m. on a Friday, we should not start working on it at 5:30 or 5:40 or 5:50 on a Friday. Okay, so yeah, repetition is a big thing to do with iteration. In a programming context, it means kind of the same thing, but in a more specific way. We have a more particular definition of iteration, which is walking through a bunch of things, one thing at a time. So this is clearly a very related idea. There's a process that is going to be repetitive in nature, and we're going to be kind of refining in the sense of working towards a final answer. But in this case, instead of saying that we've got like a document, we're going to improve it, and then a document, and we're going to improve it, and then you might even hear people say, we're going to iterate on that. And in fact, they might say that about code. We're going to iterate on that code, meaning we're going to improve it. But when we're talking about iteration within a program, we're typically talking about having a bunch of things, and then we're going to look at them one at a time and walk through that bunch of things. So in real life, we have design iteration, and in computing, we have loops. Someone says, I really thought the deadline is midnight. Yeah, so sorry, that wasn't meant to be a dig at any one particular person. That there are I've seen a lot of students come through first year programming, and the tendency to start an assignment a half hour before it's due, it is common, especially at the beginning of the semester. So that was not meant to be a dig at any one person. That is a common thing. However, over time, hopefully, as we advance in the program, we learn a bit more time management. So sorry if anybody thought that I was insulting you in particular. That was really, really not my intention. Okay. But there is a lesson here, which is when something has a deadline, you should check and make sure that you know what the deadline is and not assume. So that's a good lesson for everybody in all circumstances. And in fact, for me, I have deadlines that I really have to pay attention to as well. So in computing, we are going to use loops. As we progress in the course, we will learn about new data structures in which we can have like a list or an array or other kinds of ways where we can take a whole bunch of things and store them in one variable. So instead of just having a name, we can have a list of names. Instead of just having a number, we can have a list of numbers or an array of numbers. And that's something we're going to learn about as we progress a bit further in the course. But even today, right this moment, we have seen one type of value that we can use in an expression or that we can store in a variable, which has multiple things inside of it. What type is that? So we haven't seen a lot of types thus far of our values. So we can even go through by process of elimination. It ain't a bool, because bool is either true or false. That's not a whole bunch of different values. It's either true or it's false. An integer. So let's see. Someone said, what about a complex statement or something? So we can have expressions that have a number of values and operations in them. 1 plus 2 minus 3 times 4, etc. But I'm talking about even if we have a single value, just one, what is a type that we have seen so that one value actually has more than one thing inside of it? So it's not a bool, it's not an integer. An integer is just one number. It's not a float because a float is just one number. Yeah, someone said string in the chat. Good, because a string is a string of characters. So we have multiple characters inside of one string. So we've actually already seen a data type that has multiple things inside of it. Let me do it this way. So if I create a string, which is my name, well, you'll see that string is one value. Its type is string. And yet, you can see that it has multiple things inside of it. How many characters does that string contain? Haha, there's a ball of yarn emoji. I didn't know that. Fantastic. I mean, I'm not surprised, but that's great. Yeah, so it has 3. And in fact, something that's going to be really useful for you to know in assignment 1, which is on the assignment 1 page, there are instructions. There's kind of big picture abstract instructions. Here's the goal. And then there's some details at the bottom. Please read them both carefully because the details matter. But one of the things I told you is that Python has a function called len, which gets the length of something. So if I say, what is the length of that name? The answer is 3. If I say, what is the length of Jonathan? The answer is 8. Okay, so we've already seen that a string has multiple characters inside it. If we want to iterate over each character in the string, there's a really, really straightforward way of doing it in Python, and that is to use a different kind of loop. So what's the keyword what's the keyword we've seen associated with loops thus far in the course? The only kind of loop that we've written so far. Or at least the only kind of loop that I've told you about. Maybe you've done some independent reading or something, but yeah, while loop. Good. So now we're going to introduce a new kind of loop, which is the for loop. And the for loop is called a for loop because it starts with the keyword for. So you will notice if you try to write a program that you cannot use the word for as a variable name or a function name. It's a keyword. It is reserved by the language. And similarly, the word in is a keyword that has a special meaning for the language. And so a for loop looks like this. The syntax is for, and then a variable name, in a value, colon, then some statements. So instead of saying while true, and let me just flip over to Thonny now. So instead of, while loop, we might say while true or while x is greater than 10, do something. Instead of while and a condition, we are going to say for, and you can think of this as for each something in a value. So the value that we are going to iterate over is over here after the word in. And then here we're going to define, or we're going to provide a variable name. And what happens when we run this for loop, what happens when we run this statement is that we will iterate through this string. So we will get the next letter in the string. That next letter will be assigned to this variable, which is called letter. And then we'll keep going over and over and over through the string until we're all out of letters. So iteration using a for loop is start at the first thing, then look at the next thing, 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 until we're all done. And like I said, later we will look at other data types. We'll look at lists and arrays and iterators. But for now, we can use a for loop with a string that contains characters. So let's actually run this code. So here we will try to debug this. And so let's step into this loop. So first of all, we have to evaluate what is the value that we're going to iterate over, and that value is very simple. It's just a literal. So that literal evaluates to what it literally says, and then we are going to iterate over that string literal. We're going to iterate over that string variable, looking at one letter at a time. So first, letter is going to be J. And so you see, I didn't have to assign J to letter. Letter is a name for the loop variable, the variable that gets the current value that we're looking at and changes automatically every time we go through the loop. So here we have the letter is J, so let's print that letter. Okay, next the letter is O, and so we'll print the letter. Then it's N, then it's A, T, H, A, N, space, A, etc. And so you see this little snippet of Python code takes a string and prints one letter on each line. Okay, questions? In fact, maybe it would be a good idea, you're sitting in front of a computer of some kind right now, maybe it'd be a good idea for you to pull up some sort of Python interpreter. So maybe you have Thonny on your computer, maybe you want to use Replit, maybe you have Visual Studio installed on your computer. Any of these things can be good options. Oops. So if I open Replit over here, why don't you write a for loop that will print out the letters in your name, just in the way that I've done a moment ago? Someone says, why would we use this loop? So iterating over things is a really, really common thing in programming. So it is really common that, so for now, we've only seen this with strings, but it's really common that we're going to want to do something with each letter in a string. Or that we're going to want to, for example, if we have a bunch of temperature measurements that are taken throughout the day, we might want to do something with each of those temperature measurements. So for each temperature measurement in all of our temperatures, I want to add them up to some total and then divide by the number of them so I can get the average temperature today or something like that. So it's really, really common to want to iterate over a bunch of things stored in one value. Right now, we can only do that with strings, but we will introduce some of these other data types later. Someone says, how did I give a value to the variable? And the answer is, I didn't. The Python interpreter did. So as we execute this program, this Python script, let's see, and let's change it. Input your name. Let's make it just a little more interesting. I'm going to say for each letter in the name, I'm going to print the letter like before. So I'm going to run this program, step over this line. My name is John. And as we step into this loop, you'll notice that I never assign a value to letter. Letter is going to be assigned for me with whatever the next letter is. And I could call this whatever I want, by the way. I could call it L, for example, or I could call it C, which is short for character, or CH, which is slightly more clearly short for character. So I could do that if I wanted to, and step into this loop, and then, okay, the name is John. I got that from memory, and then each time we go through the loop variable will be assigned a new value. And the value that is assigned is whatever the next thing in the string is. So in this case, it's J. In this case, it's O. In this case, it's N. And then we've gone all the way through the loop, so the loop just ends. So I could, if I wanted to, print all done here. And so now you see we iterate over each character, print each character, and then we say we are all done. There's a good question here. Can we break this loop? Yes, absolutely. So whether we're in a for loop or in a while loop, you can use the break keyword if you would like, or you can use the continue keyword. So for example, let's say that I want to skip over all the spaces in this string. How would I do that? Well, I could check to see if the current character is a space. And if the current character is a space, I don't want to print it. I just want to go to the next iteration through the loop. So what keyword should I use to do that? What's the keyword that means don't break out of the loop, but just go to the next iteration of the loop? Continue. Good. And so when I run this program, I'll say my name is Jonathan. No, it is John Jacob Jingleheimer Schmidt. There you go. And you can see now we've printed out all the characters in John Jacob Jingleheimer Schmidt without any spaces because we skipped over those spaces. So good question. There's another question. Can we use any variable name? Yes, you can use absolutely any valid identifier. So we talked about what valid identifiers are. They can't start with a number, but they can include letters, numbers, and the underscore. So if I wanted to, I could call this the next character. Oops. If I want to spell it correctly, that'd also be good. There you go. For the next character in name, if the next character is space, continue. Otherwise, print the next character. And that works just the same way. Good question. Okay, questions are kind of slowing down there, which is fine. So let's think about. Let's go back to the slides for one thing. So let us think a bit about some problems that we could solve with iteration. So I gave this kind of contrived example of printing all the characters, but let's try to solve a problem that's a little bit more interesting. So think about this for a moment. If I gave you a string and I wanted you to count all of the E's in the string, and the combination of all the uppercase E's and all the lowercase E's, how could we do that? So if we're thinking about we're probably going to need a loop. We've got a whole bunch of characters in the string. We're going to have to check each one for something. So what is the step that we need to do inside the loop every time we get a new character? What is the step that we need to take each time we go through the loop? Right, so we're going to check if something is equal to E. So, fine. Here, I will say we will have a for loop of some kind. Actually, And inside that, we are going to check if that string is equal to capital E. We'll do something. Just capital E. No, we also need to worry about the lowercase e, don't we? So we're going to check if it's equal to E, or if it's equal to E, then we're going to do what? And the what has been suggested in the chat already. We are going to have some kind of a counter that we increment. So inside of the loop, remember we want to design from the inside out. So inside of the loop, we're going to check for each character, and actually S isn't a good name, so let's call it letter. If the letter is capital E or if the letter is lowercase e, we're going to increment some kind of a count by 1. So now we can think about how we start and stop the loop. If we're going to have a variable called count, well, I guess we should probably initialize it to something. So we want, because we can't increment a variable that doesn't exist, we can't say, well, what's count plus 1 before anybody creates count. So let's create count and make it to be 0. And then for letter in string, and you'll notice the for loop kind of takes care of some of the beginning and ending stuff for us. We don't have to think about what is the condition under which we keep going, for example. The for loop takes care of that for us. So the for loop provides a nice little abstraction that hides away some of the details of what is the condition under which we ought to continue, for example. So the only thing we had to remember when we're starting the loop is, well, if we have this variable called count, we should probably initialize it to something. And then I'm going to say there were count e's in that string. Cool. Oh dear. Sorry. Here I am typing away, and you can't see the screen, and I was not even noticing that people were typing that in the chat. Sorry. Okay, yes. So why don't I do that all again very quickly. So we said we're going to have some kind of a for loop with some stuff in it, and that for loop is if a character is equal to capital E, then we want to increment a counter, but not just capital E. So we might implement this code first and then realize, oops, we didn't count all of the E's. And in fact, let's do that. Let's show that iterative process of iterating on code. So we're talking about iterating through values, but we can also iterate on code. Let's show how this is so common that we will design something, implement the thing that we've designed, and then realize that our design was missing a particular detail. So as somebody said in the chat, let's check if character is equal to E. Now I'm going to say, well, where did character come from? For character in S. Okay. Now, the other thing we need when setting up is that we better initialize our count to 0. And now when we're all done, we can print there are count e's in that string. Okay, and sorry that I missed the chat there for a moment. Okay. Fireworks. I wonder if that's in a good sense or a bad sense. There's a question, could you use the operator plus equals? We haven't talked about that operator, but the answer is yes. We will get to that operator, but we haven't yet. In fact, today is probably when we will. So let's run this program. So let's type a string. Electric eels eat egregiously. There we go. And how many E's are there in that string? There's a question. So while you're thinking about how many E's are in that string, there's a question, why are we setting count to 0? So the answer is that inside of this loop, well, let's say that we forgot it, actually. Let's try to run this program without that and see what happens. So first of all, we're going to say type a string, electric eels, and I'll just type that. Okay, so let's step into this for loop. So our string S is electric eels. So for each character in electric eels, first we have an E, capital E. We check, is that character equal to E? Yes, it is. All right, because CH is E, and E is equal to E evaluates to true. So we step into the then clause of our if statement, and we say count is initialized, or count is assigned by count plus 1. Okay, so what is count plus 1? Well, we don't know what count is yet, so we better go to memory and find the value of count. And the answer is, oops, in memory there is no variable called count. See, count name is not defined. So if we're going to use count, we better start by initializing it. So now I'm going to run this program. Electric eels eat egregious egrets. Baby owls or baby eagles. What's it? I think it's a baby owl, isn't it? Anyway, electric eels eat egregious egrets. And it says there are 1 e's, which is kind of awkward with the plural thing, but there's 1 e in that string. Now, of course, there's more than 1 e. So what did we miss? Yeah, somebody said in the chat, the code only counts the capital. That's right. So, and there's another question. Is there any difference if we initialize count inside the loop? Ah, yeah, that's a great question. So if we didn't initialize count there, well, actually, sorry, I'll come back. That's a really good question. I will come back to it in just a second. First, I'm going to add in this bit of missing stuff. So if our character is capital E or if it's lowercase e, now we're going to count all of these things. Electric eels has 4 e's, and the string that I typed before, electric eels eat egregious, electric eels eat egregious egrets. There are 9 e's in that string. Okay, now we'll come back to that question. What if instead of assigning a value of 0 there, what if we assign a value of 0 here? So what is going to happen then? Well, first of all, we're going to type our string, electric eels. We step into our loop. So S is electric eels. And for each character, well, we start with the E. We assign 0 to count. Then we check, is this an E, a lowercase e, or a capital E? Well, yes, it is. And so we update that value of count to be count plus 1. So whatever the current value of count is, which is 0, plus 1, that's 1, so we assign 1 to count. Then we go back around again. And now look, we are assigning 0 into the value of count, which means that count goes back to 0. And so we go around this loop, and every time we go around the loop, count gets reset back to 0. Sometimes we increase it to 1, but then it immediately gets set back to 0 again. So that is the difference between assigning to 0 inside of the loop versus outside of the loop. Okay, good. So yes, I don't see new questions popping up. So let's continue looking at things. So these are some examples of problems that we can work on using iteration. So we can count the frequency of a particular letter, see how often a particular letter comes up, and you'll find E comes up quite a lot. We can also do things like for each letter in a string, we can count how many of those letters. So instead of just counting the E's, we could have a count for the A's and a count for the B's and a count for the C's and a count for the D's. We could count all of the different letters and then build up like a frequency table of the letters that are used in a string. And that can be quite handy for things like cryptanalysis, which is something that is near and dear to my own heart because it's close to my own research as a privacy and security researcher. And we could also do things like count the uppercase characters in a string. Oh, someone said, what is CH here? Is it a variable? Yes. So CH is the loop variable. So every time we go through the loop, CH is a different, well, potentially a different value every time we go through. And so the for loop itself sets CH to be whatever we're iterating through. Now we can call this variable whatever we want. Right? In some cases it's common to call it I, or we might want to have a slightly more descriptive name like letter or the, next, character. We can call it whatever we want, but it is the loop variable. It is the thing that changes each time we go through the loop. Good question. If people have other questions, don't be shy. Don't hesitate to type them in. So if we wanted to count how many uppercase characters there were in a string, how could we do that? So one approach that we could take would be, for example, to check if CH is equal to E, or CH is equal to B, or CH is equal to C, or CH is equal to D, or this is starting to get really, really tedious, right? And we said that programmers are lazy in a good way. Whenever we see something that is really tedious and repetitive, we think, boy, we could teach the computer how to do this tedious, repetitive thing, and then we wouldn't have to. Before we can do that, we need to understand a little bit more about what is actually a string. So we've said that a string is a bunch of, someone's reading ahead and talking about methods on characters. Well, we're not there yet. We will get there once we talk about objects later in the course. For now, however, I just want to think about what is a string. So a string is a sequence of characters, an ordered sequence of characters. The order matters. It's not just a set of characters where we don't care about their order. It's a sequence of characters. But what's a character? So give me some examples of characters. Go ahead, type some characters in the chat. Yep, J, A, B, C, Hridi. Oh, I see that. That's a character. Interesting. Cool. O, Q, O, D. Yep. QWERTY. All right. So we've got some examples of different characters there. Yeah. And we've got some other ones coming up. So like punctuation characters. We've got an @ sign. We've got a $sign. We've got a question mark. So those are characters. So characters are not just things like A, B, C, and the commas and the spaces that are also in that string. Characters also include these days things like a wizard symbol. What? Where in the world did the wizard symbol come from, and how is that a character? So here we have to know a little bit of history, which I've alluded to before. So a lot of early programming languages were created by people who spoke English and mostly spoke to other people who also spoke English, and very occasionally might think about the fact that like in French or Italian or German there are some accents and stuff, but mostly they were talking to other English speakers and not really thinking about all the different ways that characters could be represented. So there's a standards body, the American Society for Computer Interchange and Information, something like that. Anyway, ASCII is this body that came up with a standard way to represent characters using numbers. And so a character like capital A has a numeric value. And a computer doesn't really know anything about characters, but computers do know numbers. They are able to store integer values quite well and quite fast and do a lot of things with integers very quickly. So there was a standard that if you had a number between 0 and initially 0 and 127 and then later between 0 and 255, we could use those different numbers to represent different characters. And so you can look up an ASCII table and see that there is a particular value for the letter F, and for capital letters and for lowercase letters and for various kinds of punctuation and things like that. So the ASCII character set the ASCII representation can be used to represent characters. And there is a function in Python that we can use to get the numeric representation of a value. So the ord function, which stands for ordinal, if I say, what is the ordinal value of capital J, it'll say the ordinal value of capital J is 74. The ordinal value of lowercase j is 106. And we can convert the other way too, using the char function. So the character value of number 74 is capital J. The character value of number 106 is lowercase j. So all of these things are, so people put a bunch of great emojis in because those are all examples of characters that can't be represented using ASCII, using the ASCII coding scheme. So you can look in the ASCII table and you will notice there are no wizards, there are no people dancing, there are no fire emojis, none of that stuff. just a bunch of characters, and they don't even include things like characters with accents. So, a little bit later, so that ASCII was kind of like in the 1970s. A little bit later, in the 1990s, maybe the late 80s, an international consortium was formed called the Unicode Consortium, and their goal was to find a way of representing characters in a way that is backwards compatible with ASCII. So, for example, the capital J in a Unicode representation is still number 74, but also now we can use much larger numbers, not just numbers between 0 and 255, but numbers between 0 and 65,535. That's a much larger number. And so within the Unicode standard, we have the ability to represent characters from kind of every written language that the Unicode Consortium is aware of, and they are aware of a lot of languages, and there was still space left over. So they said all of the languages, all the written languages that we can find, that we can put into this standard, we still have a ton of space left over. What shall we do with that leftover space? And does anyone know what the answer was? Well, somebody put a sad face in the chat, and that is one example. So that's where emojis came from. So the Unicode Consortium every year says, here are a few new emojis that we've added to the standard, and that everybody who uses the Unicode standard should implement these additional emoji. And so the Unicode standard can be used to represent things like smiley faces and sad faces and wizards and all kinds of cool stuff. So in Python, it's still these same two functions. So I can ask for, let's see if I can copy and paste this. So we've said that in Python, we can have variable names and we can have strings that use Unicode characters. So I can actually ask for, what is the ordinal value? Uh-oh. Thani has done something naughty here. Ah, bother. Yeah, sometimes that happens. But I can ask Python, dear Python, what is the ordinal value of this wizard? And the answer is 129,497. So there are very, very large values that can be represented. And actually, sorry, earlier I said 65,536. That was UTF-16, but now there's a UTF-32, so we can actually have like 2 billion possible characters, so it's an unbelievably large number. And I can also say, dear Python, what is the character value of the number 129,497? And it will say it's a wizard. Or you can investigate and say, well, how about 129,498? And it's a butterfly. Or how about 496? And it is... can't see that very well. It looks like maybe somebody doing yoga or something like that. I can't quite tell. And so we have all these different emoji that are used to represent all kinds of things in our communication. And so Python gives us the character function and the ordinal function to allow us to investigate, or to allow us to convert a character into a numeric representation. So if we want to count the uppercase characters in a string, well, one way we can do that is by looking at each character and then getting its ordinal value and saying, is its ordinal value between the ordinal value of A and the ordinal value of Z? And if Thani hadn't started misbehaving a minute ago, then I would show you how that works. But as it is, Thani is misbehaving. Okay, no. All right, I've got it back now. So I could say if the ordinal value of our character is less than or equal to the ordinal value of capital Z, and on the other end, so if our character is between capital A and capital Z, then we can add something to the count. Camel cases contain capitals. And so there are 4, oops, I should have said capitals in that string. I did it again. Sorry. Like Britney Spears, now out of conservatorship. Yeah. So I could say if the ordinal value of our character is between the ordinal value of A and the ordinal value of z, then we increase the count. And so now I'm going to run that. Camel cases contain capitals. There are 4 capitals in that string. And so now we should be able to do all kinds of other stuff. So let's see. Now we've got pictures of wizards and eagles and all kinds of cool emoji. And there's a unicorn. And so many emoji. Excellent. So now we can do things like count the uppercase characters in a string, or check, does a string have more uppercase characters or more lowercase characters? We could add up the string's letter value. So if you say that the string has, an A is equal to 1 and a B is equal to 2 and a C is equal to 3, well, you could add up all those letter values in a string and, do something with it. Or we could compare 2 different strings by their alphabetical order. So these are all different problems that you should now be able to solve, or at least to attack and try to tackle. And I would suggest these would be great exercises for you to do together with your friends. And if you can do these things, then you should have really no trouble just banging out assignment 1 very quickly. I would not recommend, if you find these things to be a huge struggle, that you start banging your head against the first assignment, because it has to be individual work. Start by working on the exercises, things that you can do together, work on those together, and then look at the assignment 1 after you're kind of a bit more confident with these exercises. Okay, we've got a question here. So one announcement, I was supposed to make first is that there's more details about Lab 1 have been posted. So you've got Lab 1 marks back. Please read the news item carefully. It includes things like instructions on how to use the regrade request mechanism if that's appropriate. There's a question, will the answer keys for the past midterms be posted to check our answers? So there are no answer keys that are readily available for the past midterms, but I would say a few things. One, actually I've used some of the past midterm questions as top hat questions, so you have an answer there. 2, any question that involves code is something that you can check, and in fact, the checking of your answer will help you learn more and be more confident in your answer. So I don't have answer keys, but one thing that you can do is, you do the problem, your friend does the problem, you compare, hey, do we have the same answer? Okay, that's probably good. But also, you can use Python to check. So if there's a question that says, what will this Python script print out when it is run? Well, you can type the Python script in and you can run it. And so thinking about how would I know if my answer is correct is actually a really, really helpful thing for writing more correct answers in the future. So I'd really suggest using Python to check that. Or alternatively, if I say, can you write a Python script that will do X, Y, and Z, and you think you can, well, then type it into Python and see, does it do the thing it's supposed to do? So thinking about the correctness of your own code actually helps you write better code. So I would say that engaging with the code at that deeper level is going to be much more helpful in both in the short, the medium, and the long term than just checking, did I get the same thing as the professor? Because getting the same answer as Dr. Anderson doesn't necessarily tell you whether your answer is right or wrong, because there can be multiple ways to solve a problem. And so if you say my answer is different than his, well, that doesn't mean it's wrong. Maybe you just thought of a different way to do it. It could even be that your way is better than the first way that I thought of. So for all of those things, no, there is no particular answer key. But if you're really stuck and you say, okay, I just don't understand whether this is right or wrong, then please reach out to me, lab instructor, tutors, Eng1 Success Center, bring questions to SI. Please do reach out and try to get some answers if you are not sure about something like that. Someone said, would the top hat questions for today be opened as assignments? Yes, I will try to remember to post today's top hat questions as homework for you to do between now and Friday. Okay, I don't see any other questions, so if there are other questions, do feel free to say hi whether it's in the Top Hat chat or send me an email or what have you, and you can reach out in that way. And I would really, really, really commend to you the SI sessions, because I know many students find them very helpful in terms of, for some people at this point in the course, it's starting to feel a little overwhelming, like there are these big problems and I don't know the first step that I need to take to sort of get a handle on the problem and then eat the rest of the elephant, as it were, eat the elephant one bite at a time. I don't know how to take that first bite, and things like SI can be really helpful for figuring that stuff out. So I don't have the schedule right here in front of me, but it should have been emailed to you kind of at the beginning of every week, and I would really, really recommend that you engage with those SI sessions because I've heard they're super helpful. Okay, someone says, are numbers that are not defined as int considered character? Typing the number as ordinal of 343. So if you, let's see what happens here. So if I type ord of 343, this might only look at the first character, or it might give me an error because this is more than one character. And it gives me an error. So 343 in a string is not a character, so ord just blows up. Okay, someone says there's an SI today at 1, so fantastic. All right, well, I hope you all have a lovely rest of your day, and I look forward to chatting again with you on Friday and to seeing some of you in the lab.